Good afternoon, everyone. I'm going to talk about the tiny language model. So there are three words: tiny language model. I ask this question very often to my colleagues, friends, etc. What is the purpose of language model? So I got the questions. Sometimes I got the questions, sometimes I got the answers. The answer primarily they talk about it will answer your questions, it will understand the text, it will summarize. No. So my one-line definition to the language model is that it will take the context and generate next one word, and then it will go on and go on and go on and generate the complete text. So the purpose of the language model is generate the text, and the byproduct what we get is that question answering, summarization, etc. Here we are going to talk about the tiny language model, that the power of language model comes from the huge training data set. So the huge data training, data, and we use huge data to train the model. It doesn't have to be, the model doesn't have to be big in size. It can be small in size, and it can be much better than the actual language model. So this is what I'm going to cover: why we need, why should we create, and then how do we do it. So you might be getting these questions from your clients, stakeholders. If you don't get it, you expect these questions in near future. So this is the human tendency. You deliver much better results with higher cost. The next question is that I want the same accuracy, same results, but reduced cost or free of cost. So that question is key question that we cannot avoid in near future. The second one is that though the service providers of Azure, AWS, GCP, they give the guarantee that the data sits in the cloud perimeter. You don't have to worry about it. We don't use your data for any training purpose, etc. Your data is safe, but there are clients still with the hesitation. They don't want to expose the data for various reasons. So first of all, it may have PII information, blah, 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 many things. So how do I create a model within my premises and ensure that the data doesn't go out of my control? That's second key question. And the third question is that how do I get better control when I generate the results? So you do the prompt engineering, you get the results, and you want more accurate results. You again fine-tune the model and fine-tune the prompt and fine-tune the prompt. Beyond a point, you won't be able to do anything. So that's a dead end. You have to live with that. But beyond that, if your business is little unique and you need very specific results and much better than any other models in the market, then you don't have any other option other than fine-tuning it. That's so these are all the three questions. And so do we really need large language model? Let me take one simple use case. You want to extract the entities, the key information out of the insurance document, a typical insurance document. What you want to extract? You want to extract the insurance number, the name, and the root cause of claim, etc. Will you ask who is the Prime Minister, who is the President of US? You will not ask. So at any point in time, given a business domain, you don't need a unique or a gigantic large language model. You need very specific and accurate model. So if it is small in size, it is easy for you to manage. So this picture clearly depicts the difference between the multi-purpose large language model and the single purpose tiny language model. So the tiny language model will do only one activity. If it is a classification, it will do classification. If it is a question answering, it will do question answering. If it is a summarization, it will do summarization. If you want to do translation, it will do anything that large language model can do. The small language or small language model or tiny language model can do, but large language model cannot defeat the tiny language model when it comes to the business domain. So I'm not saying that the tiny language model will compete with large language model, but it will complement. I'll explain why, how, etc. So first of all, we have GPT or Claude, or there are many large language models out there in the market. So why should I create tiny language model? So is there a real need? So these are all the reasons why we need to look for alternative options of creating the tiny language models. The first one is the data security. So let's say if you are a company where you cannot expose the data to any cloud environment and you want to get the benefit of all the language model, then you have to create your own model. Second option is that the large language model understand that every token is charged. So it is pay as you go model. So you cannot say that I invoke 1 million calls, can you reduce the cost? No, there is no option of that sort. And then large language model, you give the prompt, you get the results. After that, what will you do? If you want to improve, and if there is a drift in the data, will it automatically identify and change the prompt? No, it cannot do. But in tiny language model, if you create a feedback mechanism, we can still do that. And hallucinations. The model hallucinates because it has seen many things of this world. It is greedy in talking to you. It will generate more and more tokens. So there is a philosophy. The model thinks when it generates the tokens. So its real thinking power is while generating the token. That's why you give more context, it will think more. So in large language model, you will do a prompt engineering and then few shots. If it still hallucinates, you don't have any control to arrest it other than creating the fine-tuned model. And the fourth one is, we should not underestimate the small language model or tiny language model. It can give the results as good as large language model. Sometimes, I won't say sometimes, most of the times it is better than the large language model. So what do you need to create the tiny language model? Just two things. One is that input and output. So if you want to create any model, then you need input and output, and then you need hardware. So this is the place we have a catch, and this is the place I say that the tiny language model will not compete with large language model, but it will compete. The reason is that you have a data and you want to go to production day one and you don't have labels for it, then you start with the large language model, go to the production and observe the outcome, persist in the database. Over a period of time, I call it incubation time. So you have both input and output. Now you create the model. That model is your tiny language model. It doesn't have to be as big as the large language model. So then the moment you create the tiny language model, you cut the cost of the token cost. Your inferencing is free of cost. You just host the model. So we created 5 tiny language models so far, and I'm going to pick up one specific use case. So Llama 2.0 is something released in 1 or 2 months time frame. Llama 1.0 came prior, but we started this language model creation approximately a year ago. We started the journey with GPT 2.0 itself. So we took the GPT 2.0, and there are many mistakes we made, and we learned many lessons from the mistake. I started creating the model right from the scratch, the biggest mistake I did. We should not create any language model right from the scratch. It's pathetic. The reason is that the moment you create from the scratch, you lose the knowledge about the world. So the real power of language model lies in the knowledge about this world. So if you want to harvest that, then don't ever try to start from the scratch. Point number one. Point number two, what is the right hardware? When that time we used hardware, and we created the first version of the model, and then we extrapolated same thing. If I want to create the model with 10 GB data, it results in 6 months. So then we went and explored about the hardware. So this is the summary of the entire experience. We used, now the recent model we used GPT 2.0, 7 billion parameter, and then we used 500 samples. Again, the question is that what is the right set of sample size, 500 or 1000 or 2000, 10,000? The industry standard says that anything more than 10,000 is good to start with. But we used 500 and we got the very good accuracy. I'll talk about that next thing. You ideally need A100 kind of machine. If you get H100, nothing like that, it's very good. But we used A10G machine, which is nothing but MLG12X machine. And the cost of the machine per hour is 7.09 USD. And we trained the model for 30 minutes. And the inferencing cost is 0.05 USD per hour. So 60 conversation takes, so our sample is nothing but a conversation. So I'll go to next slide. So the last point, the 60 conversations, 30 minutes, 10 minutes, I'll explain in the upcoming slide. Now, there are multiple ways by which you can fine tune the model. You take just the architecture and you train the model just like any other machine learning model. That's one way. The second way is you take the pre-trained model and touch and modify every single parameter of the model. For example, GPT 2.0 is 345 million parameters. In this case, if you take Llama, it is 7 billion parameters. You touch and modify every single parameter of the model. This is that. Don't do this. This is advised. You take the pre-trained model, and then you have a model, you attach a matrix, and then you don't touch the actual weight of the model, you touch and modify only the attached matrix. Then once the training is done, the dot product of attached matrix and the actual matrix will get you the final result. This is called LoRa method, low rank adapters. It's called adaptation, business adaptation, adapters, etc. I'll give you a statement. If you understand this statement, you will never forget this concept. The statement is, let's take GPT 3.0, 175 billion parameters. 3.5, 4.0, we don't know how many parameters they used. 175 billion parameters. Let's say for my company, I want to create 25 different models. Hosting one single model itself is too much. It took a lot of money, energy, and time. If I create 25 models, then they have to replicate the same thing for 25 times for my company. And there are 1,000 companies out there in the market. So it's technically not possible at all. So then what you can do is, you have a master copy and you attach a new matrix, and then that matrix will be fine-tuned. Then when you do the matrix multiplication, and final outcome will be decided. So therefore, this point will help you to remember the concept of LoRa. Fine-tuning the gigantic model is not required. We attach a small matrix, only fine-tune that. So this is what we did. There is one more method called quantization. The quantization is that the bigger memory footprint taken by the model is, just because we use floating points. So floating point can be represented in 64 or 32 bits. So therefore, it consumes a lot of memory. So assume that if you do the same operation using integers, then it just needs 4 bit. So the key concept of quantization is, we take a scaling factor, convert all the floating points to integers, and we manipulate every single operation using the integers. That is called quantization. So we use that method. So training is faster and hosting is easy. It will use very less memory to load the model. So this is what we did. Better accuracy, faster, easy to fine tune, easy to manage, etc. Very importantly, we don't lose the knowledge about this world. The pre-trained model is used as it is, and we inject the real injection happens the fine tuning. So this is my actual input, and this is the output expected. So this is what I want to generate. If you look at, I want to formulate this challenge as question answering system. So I give this the instruction as a question, and I want to generate this as a response. But you may debate with me, it is combination of multiple things. It's a classification involved because it's a data sample, the conversation between the agent and the user about an issue. So what they discuss about is the data all about. Out of this conversation, what I want to do is that what they really talk about, what are the concerns. If I want to summarize it, I want to take few notes for next call, etc. That's the whole challenge all about. So this can be looked at as a classification, multiple classifications, multiple question answering, a summarization. So since it is a language model, it can learn function of function of function. So therefore, I put all of them in one go. This is the toughest challenge that we can give it to language model. So the key customer concerns, reasons for delinquency, legal issue, all those things, the model has to go and analyze the sample and get the insights out of it. So this is the input and output expected, and the evaluation metric here is perplexity, and we tracked the loss of the model and the manual evaluation. Any model that we create as a process, we give it to SME. SME's sign-off is required before we get into the production. So this is the perplexity score. There are 2-3 hints I give, which you can use for any language model creation. One is that the first observation is that if the perplexity score is less than 1.5, it's very good, meaning you can interact with the model. So that's what our target was. So we started from 2.5 and we did it for 5,500 steps. It gradually reduced, and then the validation loss came down, and then it saw the flat surface. We stopped it, and beyond this we don't want to go for 2 reasons, because just because we have 500 samples, one. Second thing is that we saw the flat surface in the loss, so therefore we stopped it. And then very high level, I would say the F1 score is close to 60%. You may ask me the question. So if it is a question answering system, how do we calculate the F1 score? So as I told you earlier, it's a combination of multiple things. If you look at the whole output, if you treat as a response to a question, then you can use blue score, rogue score. We did that, and then I call it intrinsic evaluation. So extrinsic evaluation is with respect to business, how good it is. Is this coherent and cohesive? Can be explained using blue score and rogue score, but how accurate it is cannot be explained by blue score and rogue score. Then we took the actual key value pair and treated it as a classification challenge, and we calculated. Overall, we got 60% F1 score for the classification thing. So now the important thing is that I have a data set and I want to go to production. I don't have label. Then you use GPT, and so there is no doubt about it. The large language model is top in the leaderboard, but once you complete the incubation period, the point what I claim is that you don't have to rely on large language model forever. You can save some cost. The step one is that anyways you have to have a solution and go to production. Once it is done, the next question what you get from the business is that how do I reduce the cost? If you want to reduce the cost, then you have to fine tune the model. And then there are challenges with the tiny language model as well. For example, it is not good in solving the math. For example, person A gave 20 rupees to person B gave it to person C, then the person C used 5 rupees of it. Now what the person A has, this is very hypothetical. Keep this aside. It is okay for research, but business does not need these kind of things. Business needs simple, straightforward most of the time, 90% of the time. So then the red marks, you can forget about it, and you can live with the green ticks. It's good. So I created this slide 2 days ago. Now my opinion is changed. I'll not use I'll not use RLHF for this. The reason is that it doesn't make sense to use RLHF. Point number 1, RLHF is not meant for classification, simple question answering, simple summarization. RLHF is meant for very complex question answering system. But as a next step, so the thumb rule is that if you have a classification challenge, if you have a simple question answering, you live with simple fine tuning. You have a very complicated summarization task. If your output has to be coherent and cohesive, it has to be a text which will interact with the user, then you use RLHF. And then there are challenges. If you want to really fine tune a model, the best approach is that you will look for the spoon feeding method. Are there any cloud service providers? Give the APIs which I can straight away consume and create the model is something you will look for. Azure gives only for classification. They don't give it for question answering. AWS gives a notebook. You can fine tune the model. GCP gives a method for RLHF as well. So pick and choose what kind of, based on what kind of infrastructure you have. So you can use cloud infrastructure to train, or you can download the model yourself and fine tune it. So the conclusion is, tiny language model is something you cannot avoid moving forward, 1. And 2, it is cost effective. And third thing is that you must do over a period of time. We are looking for next 12 months time frame. So in next 12 months, you may take up some challenge and you go to production and ensure that you persist all the information, input and output. You may create a tiny language model or fine tune a model. You may not do it, but your infrastructure should support that. You have to have both X and Y, input and output should be there in the database. And when time comes, you will realize that the need for creating the fine tuning, creating the fine tuned model, that's when you will remember these concepts. And then data privacy. So you don't have to worry about, am I exposing the data to the cloud platform, what will happen. If you want to create a model on premises, you can still do it.